Okay. Well, hello everybody. This is a live stream, and I am on the air. Here it's a Friday evening, 9 o'clock Eastern Time on in the United States. I'm David D. Hillstrom, your dissident science guy, also a critical thinker, trying to get you science woke. It's your science therapist. Today we have a really interesting article I'm going to be talking about. I'm going to wait for people to come on board. I've been announcing this because I've been trying to do the events on YouTube, and it seems like that doesn't want to work for me. So I said, okay, I'll just do the live stream button. Works real easy, real fast. So, anyways, hoping to get some people joining here. But there we go. It says live. Making sure we're good. I'm here in Boca Raton, Florida. So there we go. Oops, got to turn out all the volumes everywhere. Make sure I'm not feeding back here. But today I'm going to talk about actually an article that's really, really interesting. I think I'm going to probably do a video on it anyways, but it's more interesting to interact this way. Try to answer questions as well. So look at comments, answer questions of the people who are live, and take a look at some things I think interesting. And I've received this article from one of the great critical thinkers of that we know of in our circles. His name's Stephen Crothers. Stephen Crothers is a great story as well, which we're going to have on Science Woke. I'm trying to figure a name for it, and I'm going to maybe ask my audience today a little bit about that. But basically, we're going to have a lot of articles on sciencewoke.org about people who have been suppressed, who have been, I guess suppressed is a good name. I'm trying to come up, I was going to label it fights, suppress. Anyways, could be listed as a lot of different things, but the idea is these people have been, man. See, there you go. I'm got a master's in linguistics, and I'm without words for this. People who are being suppressed, people who are being ousted, people from universities, people who are being squashed by the powers that be of big science. That's something that I think is really interesting in the stories. We've got Helton Arp, we have Bill Lucas, we have Stephen Crothers, we have Dr. Ricardo Carazani, and many others who have been persecuted, ousted, ignored. Ron Hatch, the guy in our group that knows more about GPS than anybody. He's got over 30 patents in GPS, and he claims very rightly so that GPS shows the problems with relativity, not the supporting it. Even though we hear that all the time in mainstream media, it ain't true. So hello, the one, we got somebody here. All right, take some time for people to join up. So especially when I don't announce it, but people do look at it, and the people who pop by and see that it's live. But thank you very much for coming by, everybody. And I am for sure going to be talking about a number of topics. But the one big article tonight, which is I'm going to concentrate, has to do with this idea of going against mainstream or big science and the reaction from them. In this case, whenever there are people more professionally claiming that something is wrong, the kick. I can't. I don't know. I'm not even. I'm relaxed. Didn't drink anything funny. I'm not being able to put into words this whole thing of what it is. People have a swift reaction, a swift comeback to what the other physicists claim as something is wrong. They'll claim all kinds of things, but they'll be swift. Their reaction is swift, and that's what we're going to talk about today. So why don't we take a look at that? I've got a couple of people. Thank you again for coming by, you guys. Greatly appreciate it. I'll just say hello to you in the chat. I don't know who's here. Hello there. Friends or enemies, but on the internet you can be anonymous. So anyways, let's take a look at this article. It's definitely really, really, really worth it. It says Danish physicists claim to cast doubt on detection of gravitational waves. Now, I do have a video about this, and you can go to my YouTube channel, youtube.dissident.science.com. Of course, you're there now. And if you search, you will search for gravitational waves, LIGO, I think. My goodness, it's only 9 o'clock here in the evening. But LIGO, you can search for LIGO, and I do talk about it when they say they detected gravitational waves. Of course, when they did that, they immediately gave out, of course, Nobel Prize. One of them to probably the only person I know of today that I would consider to be a person who's made almost their entire career on relativity, general relativity, and that's Kip Thorne from Caltech. When I had my mom from for my movie Einstein Wrong in 2005, 2006, call around to many universities. You can't really find anybody who specializes in relativity because it really gets you nowhere. It's useless. People say it's used all the time, that the universe can't work without it, but there's no, and it's used for practical things like GPS, which is not. But anyways, this is all related to LIGO, so you can go and take a look at that video. It's been a while back, so but we can take a look at these headlines here. It's pretty interesting. So you got Danish physicists claim that cast doubt on the detection of gravitational waves. This is from 1031, so it's just a couple of days ago from when I'm making this video. And it says signal to noise. I don't know if this is part of the way they write articles at rastechnica.com. I'm going to make everybody yawn tonight. I don't know what that means. They say it's because you're lacking oxygen. I don't know if that's true. But anyways, of course, LIGO responds. There's absolutely no validity to their claims. Now, it's interesting because this is where you can see right away, this sounds very, very, very similar to politics. I'm a progressive. I believe that we need this income inequality is absolutely absurd. It's not that I believe. It is absurd. It's very dangerous for our culture, even worldwide. Here in the United States, we now have 3 individuals who have the same wealth as the half of our country. And because of that, we have a lot of people who are quote-unquote progressive and who are fighting and realizing that our politicians work for rich people, and of course they don't care about us. And of course there is the politics that go on all the time. So if you, for instance, like here, to give an example, I live here in Florida. I know a guy, his name's Tim Canova. He is a law professor who is running against Debbie Wasserman Schultz. For those of you who don't know that, she was the chairman who was ousted from the Democratic National Committee because of some scandal of fixing the election against Bernie Sanders and for Hillary Clinton. Well, he had a primary against her, and their exit polls showed that, in fact, he won. So they went to court, and all the paper ballots here in Florida, in Broward County, just one county south of me, they have to keep those ballots for 22 months. Well, the moment he asked for them and went and got a court order to get them, lo and behold, they destroy them. Against federal law, nobody does anything, and of course, he contacts all the Democrats in Florida. Nobody does anything. Those people who are in power, they have money, they have power, they have intimidation. People wash up on shore, all kinds of stuff here in Florida. What I'm saying here, folks, is that the politics is very powerful. And when you say to them, wait a minute, you can't destroy the ballots, it says, there's no validity to any of your claims. I don't know what happened. there's all kinds of hand waving. And when you read this LIGO response, there's absolutely no validity to their claims. I mean, they're not saying it. They don't say, well, they're saying claims. They're saying there's no validity. There's no statement. This is just a general statement, just like, how do you say? They're just saying no. So the Danish physicists claim to cast doubt on the detection of gravitational waves, and they say, nope, you're wrong. Your doubt is wrong. Now, we're going to read through this article. It says the Nobel Prize winning first direct detection of gravitational waves was announced in 2006 is being called into question. LIGO calls shenanigans. No, yeah, I'm not sure I understand that sentence there. Enlarge. Well, the Nobel Prize winning first detection of gravitational waves, announced in 2016, is being called into question. LIGO calls shenanigans. I guess that means they're calling that claim shenanigans because of something. I don't know, maybe they don't like the people. But again, you see right away, very important, the Nobel Prize winning first direct detection of gravitational waves. So you can see this is already, even by this writer, placed in a very high place. When you look at the power, speaking truth to power, as they say in politics, well, speaking truth to big science, you can see that the journalists are on their side because they want to be associated with the big power. They want to be associated with the big names. They want to be out there. So when these things go out into the news, which go worldwide, they want to be part of that. It's important for them to appear in this. It's important for them to write articles about this. They're not absolutely interested in truth at all. And in fact, I'm going to tell you how this is going to end before it even ends, because I've seen this over and over and over when someone comes out and says Einstein's relativity is wrong, or the Big Bang is wrong, or there's this other thing that's wrong. And they go through the same kinds of things. The first thing is, of course, there's absolutely no validity. So you can look at the wording of this. Absolutely, of course, is extremely strong linguistically. No validity. There's nothing valid to their claims. So those are very strong. And then, of course, their claims are not proof. They're not proof. So anyways, let's keep moving on here. Just making sure. I see we've got some couple people watching. So hey, thank you very much for watching again. I'm going to put this down with the title so people can know about it. So when you're watching this as a recording, I remember that lots of people will watch this afterwards, even though we only have a couple people watching right now today. And again, I need to announce this ahead of time. The first direct detection of gravitational waves was announced on February 11th, 2016, spawned headlines around the world, and snagged the 2017 Nobel Prize in Physics, and officially launched a new area of so-called multi-messenger astronomy. Okay, well, I'm going to read this before I go into it, and I can go back to it. But a team of physicists in the Niels Bohr Institute in Copenhagen, Denmark, is calling the detection into question based on its own independent data analysis conducted over the last 2 years and a half. I'm not even clapping to say that these guys are right or wrong, or that this is right or wrong. I'm clapping that someone's actually testing this. There's two things that are really important here. First of all, this is the Niels Bohr Institute in Copenhagen, Denmark. This is a very well respected institute. Secondly, they're calling that into question based on its own independent data analysis. So what it's doing is just looking at the data, and maybe that means they gave the raw data out, and they're looking at it, and over the last 2 years, and they're not seeing what these people supposedly were seeing. So let's keep going. This is really great. I gotta make sure you can see it, because my scroll area is different from what sees on the screen here. As New Scientist reports, the group thinks that the original gravitational waves, let me move this, there you go, the original gravitational wave signal detected by the Laser Interferometer Gravitational Waves Observatory, LIGO, was an illusion. The researchers allege that the calibration mistook patterns in the noise for a signal. Okay, let's talk about this a little bit. The whole thing is that he's talking about signals. Now, who talks about signals a lot? One of my favorite guys. In fact, one of my favorite critical thinkers, one of my favorite science woke people, and one of my favorite big science warriors, Dr. Alexander Unziker. He talks about signals all the time, especially in particle physics. They get signals all the time, and what they're going to say is, oh, you see this blip here? That's the Higgs boson. Oh, you see this blip over here? Oh, that's gravitational waves. We've detected them. Well, let me put it this way. They spent millions and millions and millions of dollars and many, 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 many years looking for gravitational waves. They're going to find them. So right away, we've got a couple of things that they were saying that a new scientist reports the group thinks that the original gravitational wave signal detected by LIGO was an illusion. Great. They're looking at the signal. That's what we can't see in the particle physics, and we don't get that raw data from the big accelerator, the Large Hadron Collider. So let's keep going. The researchers allege that the collaboration mistook patterns in the noise for a signal. Okay, I did read that. The magazine oddly touts this as an exclusive, but group spokesperson Andrew Jackson has been banging this particular drum for a while now after first experienced misgivings about LIGO's analysis as presented during the February 11, 2016 press conference in Washington, D.C. Okay, this is interesting too. Now you're seeing that journalists are fighting over it as well, because all this is territory. They're not interested. You notice how the wording they use, they want to make it dramatic, so they want you to worry about the fight and not necessarily worry about whether or not they're looking at truth. So here you're saying that the magazine oddly touts. So you can see that this person who is writing this is talking about, oh, this magazine says this is an exclusive. But of course, Andrew Jackson has been banging this for, so if you look at this, it's going to Forbes. So again, what this is territory. So in the middle of us trying to be science critical thinkers and become science woke, we are having to wade through bunches of wording that both the physicists, the big science, the mainstream physics throws at people, the fights between the journalists trying to take care of their territories, whatever you want to call that, and that's quite amazing. So the group's original paper was published in the Journal of Cosmology and Astroparticle Physics in August of that year. And there has been considerable back and forth within the physics community about Jackson's claims since. So of course that's going to be interesting to everybody. If you want to make any comments, you can. I am watching the chat here. I got my other computer right here, and I got my over here. And so let me know. Anyways, for people watching, welcome everybody. Thanks everybody for watching. I do pop on here. I need to announce this. I apologize. I don't announce this all the time because I'm having problems with. I used to be able to set up those events and they seem to work, but last time I tried did not. So I'm just clicking the button to go live. Somehow I need to announce that. I think there is a way. But anyways, let's keep going. So the physics community. So they're saying that the physics community has been talking about this for a while. Andrew Jackson and his group have been saying for the past few years that LIGO's detections are not real, says LIGO Executive Director David Ritz of Caltech. Of course, this is the LIGO, at least he's being civil right now. Their analysis has been looked at by many people who have all concluded there is absolutely no validity to their claims. Now listen to this. Here's the problem. Here is the problem. Again, there's absolutely no validity to their claims. I mean, this is super strong. If I were them, I says, well, they are opposing our claims. We've looked at them, and to our best of our ability and knowledge, and we've had many people look at them. There's we do not think that their claims hold water. this whole thing has absolutely no validity to their claims. This is one of the problems with mainstream and big science. They make these extremely strong statements. I'll give an example. Another video I did about Neil deGrasse Tyson. Somebody actually asked him, could Einstein be wrong? His first response was laughing, literally. And so it's not, he's going to say, the answer, every scientist, every critical thinker, every person on the planet, anybody who has, any engineer, anybody who is a true scientist, true critical thinker, and a science woke person says, of course, you could be wrong. Absolutely. But these people, they go to the absolutes. They set themselves up. This is why so many, 99.9% of the scientists and engineers out there, and a lot of physicists, the majority of physicists, don't believe this. They read this with as much skepticism as I do, and you probably are, hopefully, reading it now and learning about that. Many of you already have because you are dissidents. But anyways, it is something that is super refreshing to see real physicists out there who are experimentalists saying, look, we're not seeing the signal that you're seeing. We're not even talking about whether even if it's gravitational waves, because that's what my, again, look up dissident scientist, LIGO. Look it up. I have a video on it, and they'll tell you why we can't believe any of this right now. It comes down to one simple fact. Spoiler alert for that, but it's very well worth you looking at that video. But basically, we don't know what light is. We don't know what gravity is. We don't know how that interacts with electromagnetic fields. We don't know how if we don't have a model, how do we know how light travels through the universe? How that works? How do we know if we don't know what gravity is physically in reality? It's just bending of a fictitious space-time, which we have no idea what that is. How can we do anything? We can't. Without any model, you can't do that. Again, numerous people in our CNPS, the Chappelle Natural Philosophy Society, of people who have looked at the problems and who are fixing those problems and have new models. Like I always say, we have models and we can describe what's going on. Now, whether or not my dad also, you want to look this up? My goodness, folks, it's absolutely worth it. Remember to subscribe to my father's channel, Particle.guru. So youtube.particle.guru. Yes, there's a guru domain name. So what you want to do is go there, look up Particle Guru, LIGO, or gravitational waves. I believe my father has something on that. It's very, very good. All right. So anyways, he says their analysis, and there's absolutely no validity to the claims. It's really too strong of a statement. No scientist would say that, so I just say that LIGO executive David writes of Caltech, you are not a scientist. You are just defending your territory, and that's all, because you've gotten your Nobel Prize. And you know what's really going to be one of the great things in the future is people with Nobel Prizes. We're going to go back and just say, we got a Nobel Prize for a neutrino. Doesn't exist. Oh, they got a Nobel Prize for finding gravitational waves. Doesn't exist. And I think, in my opinion, Nobel Prize in physics is going to fall further and further down and will not be worth something, and something else will come along. Maybe our organization's awards will be looked upon as favorable, and all of a sudden our award will be better. Who knows? And no, I don't do that because we want to become famous and ours is the best in territory. It has nothing to do with that. It's for honoring great scientists. So don't play the reflective game, okay? I'm not interested in the reason I say that is because this would be doing the right thing. That's it. So let's keep going. So Wrights characterize the New Scientist article as very biased and what do you think their data is? What do you think their entire experiment? It's very biased and it's very sensational. I mean, it's so sensational they announced it in when? February 16th, and it says right here, they announced it February 16th, and the Nobel Prize was already in the 2017. How fast can you, was it that everyone was looking at it? It was that important? That was, come on, guys, come on. So it's really hypocritical to say that because they're talking about themselves. Hey, Proto X, hello. Oh, we got some fractal truth. Hey, particle theory is the main problem as I see it. Light doesn't travel. Okay. Fractal truth, no, fractal truth maybe. You're not, there's a lady in our group, and she is the fractal lady, so probably not. Particle theory is the main problem as I see it. Light doesn't travel. Don't know, not sure. Anyways, we can talk about that. Let me just keep going here in this article. LIGO spokesman David Shoemaker of MIT thinks the controversy all boils down to a misunderstanding about LIGO's methods for analyzing its data. You think? Oh, I mean, that's like saying, well, that, of course. It's not like, listen to this. I'm a linguist. I tear these things apart. Maybe it's one of the reasons I became a critical thinker in science. LIGO spokesperson, okay, you get who that is, right? The people who have to defend what they're doing. David Shoemaker of MIT thinks. Now, when a person say they think, that means it's so funny because they're absolutely certain the criticism is wrong, but they think something that's what is a total truth. It's amazing how, when you read between the lines, how you can see the fallacy. This is just like the politics you see as being a progressive. You see that, how people manipulate stuff. So when they make those absolute statements, it's when they are least correct. And when they make wishy-washy statements, is when they are correct. Why? Why does he say he thinks the controversy boils down? Because he's trying to imply that maybe there isn't a controversy. I think what these young kids are saying is that we didn't plug in the machine to the 3-prong, we plugged it into a 2-prong, and because of that, it's wrong. I think that's what they mean. Those little kids. That's why you watch my channel. You wouldn't have caught that, huh? The thinks the controversy also boils down to misunderstanding about the methods for analyzing data. That's what they said they're doing. It's not a think, it's a fact. Hello? But again, that's how they use words. So when I know someone's got something against me and I want to belittle that, I said, I think their argument is saying that I shot their grandmother and they have an actual videotape which has now gone viral on the internet, and I think that's what they're talking about. Oh my gosh. Jackson et al. Let's see, misunderstanding and came to it skeptically. I think skepticism in science is a really important thing. Yeah, it is not to you, because you're not buying this. It's important. So maybe what they're going to say is, oh, it's important for you to disagree, but you're wrong. It's great, Our students come and they have this idea, they listen to that Dave D. Hilster guy and they say the Big Bang's wrong. Of course, everybody knows that's not true. And so they come and we say, well, it's good to be skeptical and look at those things, but you'll come around. The Big Bang's right, so you want a degree, then that's what you do. If you want to write your thesis about how the Big Bang's wrong, we're not going to let you do that because you would look so stupid. Or maybe you would be the smartest guy there, but, I think the skepticism in science is really important. You have to question results. But these are oh, here it comes. What's their other argument? This is a big one for big science. This is big for theoretical physics. But these are complicated data. Remember what? The book you must read. This is a book you must read. I don't know how many people have this, but must read it. This is what Dr. Alexander Unziger says. He talks about it's so complex that you need to understand it. Margaret Wortham, Physics on the Fringe, went to one of our conferences. I'm in the book. My name's in here, and she's like a big time writer that goes around on NPR and all that stuff. Well, the CMPS are full of people who love science, but the universe is really complicated, and the way it works is complicated. The data is complicated. Physics, the particle physics data is complicated. So what is he doing? He's setting us up and setting these Danish physicists up to be, well, they just looked at it in some superficial way. They're not the big brains, the people from LIGO, their brains are like this. They go up here and they're like this big. And so they're just inherently smarter. They have much more computing power. And you're not going to arrive there, you Danish physicists, you children. They are not simple to understand. Certainly nothing they've done gives us any reason to doubt our results. Again, listen to that. Nothing. Now, if these people were real scientists, well, we've looked at it, and here's why we're pretty sure why it's wrong. No, they just come out and say that. But could it be? Yeah, we're reevaluating. Well, they've done gives us any reason. Again, look at that. Here it is. Oh, I think there's a controversy. I think there's one. And it's really important that, to be skeptical. And, this data is complicated. It's not simple to understand. These are common things. It's almost like, how political parties around the world, or the rich, or the mass media, which is owned by the rich, who control all the things that they say that their mouthpieces say. They pay these people in the United States $30 million a year to just read what they say and be even convincing. They're actors. They're no longer journalists. Well, this is big sciences. This is particle physics. This is mainstream sciences speak. Well, I think it's a controversy. I think this is the controversy they're talking about. It's good to be skeptical and, to question results. But, it's complicated data and it's not easy to understand. And there's certainly nothing that they've done that gives us any reason to doubt our results. Okay, LIGO, while LIGO has gained a not entirely undeserved reputation for excessive secrecy. Another problem. Transparency. Did I tell you to read this book? I have 2 videos on it. If you don't want to read it, go and I talk about some of the stuff in there. Has gained and not entirely undeserved. So this person, who's a journalist, who sounds very mainstream because of the way, well, it's hard to say because he's just talking about the scientists, but anyways, he says not entirely undeserved reputation for excessive secrecy. Why do you think that is? Why do you think they destroyed the ballots when they were against federal law right here, really close to where I live here, when Tim Canova said, hey, there's shenanigans because our exit polls say I won and Debbie Wasserman Schultz, you lost. They just go ahead and destroy those and they're secret. They never showed them. They have all the secrecy, excessive secrecy. Shoemaker says the collaboration has spent a great deal of time interacting with Jackson and his group over the 2 years to improve their understanding of the LIGO methods. You will watch. I got to get something. Where's something? Oh, here we go. Oh, I can't do that. It fell down. I can use this though. Here we go. I'm going to use you are getting sleepy. Jackson and his group, you are getting sleepy. We will improve your understanding of the LIGO methods. You will be fully indoctrinated and believe everything that we say. You will not question anything. You will not use your critical thinking. You will use your lizard brain, as Jimmy Dore says, my favorite progressive news guy on YouTube, lizard brain to react to our stuff, and we're going to turn that lizard brain off so you will understand. Help us, please. Help us. I know, Andreas Cease, I owe you a bunch of videos. Anyways, amazing. So Here it is. We spent a great deal of time interacting with Jackson and his group. They always speak nicely. They want to speak nicely because they're children, and these children are too stupid. They're not smart enough to understand yet. They haven't. Their brains haven't fully developed. Well, they'll never fully developed to our brains. I've got to get one of those big brain things. Like those big fake old brains. So, anyways. Because that's what they're feeding this. And of course, we want to improve their understanding of LIGO methods, including extended visits to Niels Bohr Institute, inviting Jackson to discuss the issue in depth in teleconference with the LIGO team members, including extended visits. Okay, so they have done video conferencing, extended visits. So, anyways, I'm going to get to you guys' comments here in a bit. So, I see people coming and going, but I appreciate it. Anyways, we're going to keep moving here. So if LIGO's response, whenever that drum begins banging anew, sometimes comes off as a bit exasperated, there's a very good reason for it. It's funny because one of the things is one of the most common things when you ask any physicist at any university who's a theoretical physicist about have they ever received anything that says Einstein's wrong, that the Big Bang's wrong, or any of those things, they go, yeah, we receive lots of them. And their response is the reason they get those is because people want to become Einstein. They want to become famous. They think it's easy to do that. It's not. The only way you can do it is to learn everything in the universities and go from there. But it all comes down to this idea that you have to, they go after it for many years. So what they're saying is they're becoming exasperated because they're spending a great deal of time, last 2 years, over 2 years, to improve their understanding. That is to indoctrinate. Look at this is the sentence of the entire article. That's the sentence of the entire article. And so what it means is they've been spending over 2 years. And you think that it's funny because if I were to ask a university professor of particle physics and he would say, yeah, we get them all the time for the last 20 years I've been getting them. He says, you know what I'd say? I have a response for it. So if you see somebody or you hear somebody, this is your response for it. Oh, and you say, oh, professor, do you get stuff that says, mainstream physics is wrong? Oh, yeah, all the time. For the last 20, 30 years I have. Here's my cut. Here's your comeback. Well, maybe because they're so persistent. And has there been many? Oh, yeah, many. Have you ever thought that's because it's actually wrong? That people aren't, it's not just like random people that there's some disease of a certain percentage of the population who likes science, who gets disease of I want to become Einstein, so therefore I just pick him and tell the professor he's wrong. No. Have you ever thought that the reason you hear from him for decades and many different people, that he's actually wrong? Reasonable doubt. There we go. Now this is going to be really good because they're going to set this up. The way that this is sets up as these articles set up when anybody actually challenges them from within. Then they get to the reasonable doubt. Because the whole thing is if there's any reasonable doubt, then of course we can't accept that. Or if there's any reasonable doubt about our data, of course, then we would have to reject it. This is a field long riddled with doubts. There we go. Oh, if it's long riddled for doubt, maybe there's a problem with it. In the 1960s, physicist Joseph Weber of the University of Maryland designed and built his own detector using resonance bars, and he would expect vibrate a response to gravitational waves. Columbia University physicist John Levin described the operators in her book, Black Hole Blues, using the guitar string analogy. A solid aluminum cylinder, range of as guitars means it isn't easy to pluck, but when one of the natural frequency of strong gravitation would ring the bar like a tuning fork, Weber claimed that he detected a signal in 1969. Yeah, he did. You know why we know for a fact he didn't detect it in 1969? Because I have a Nobel Prize for it, and it was for my work in 2016. It wasn't for his work he didn't get the Nobel Prize. It's so funny. Alas, nobody else could replicate the result, and Weber's professional reputation was never fully recovered. And we were the benefit of it because we pretended to detect the gravitational waves because we don't know, even though we don't know what gravity or even light is, or even how these detectors work in reality. But anyways, we detected them, and we got Nobel Prize. So, hello. Then in 2014, the Bicep 2 collaboration was hunched for I almost said the word fairy tale. Now, is that a slip because I know this is such a unicorn world, and in my mind I'm reading this like, why am I even wasting my time on this? Which hunts for telltale signature of gravitational waves and cosmic microwave background. The leftover radiation from the Big Bang announced that it had detected indirect evidence of these ripples of fabric of space-time. You know what I think about fabric of space-time. Hey guys, hello. Thank you for watching. I know you're there. I'm going to keep moving here, but I want to maybe get down here and say hello to everybody. Fractal Truth says a particle theory is the main problem as I see it. Light doesn't travel. I'm not sure what you mean by that. Check out YouTube channel Theory of He has many interesting things on magnetism. Okay, I will take a look at that. Duplicat. Oh my God, I love Jimmy Dore. Glad you know about him. Absolutely. In fact, I've got a big surprise coming up because once we get our Science Woke website up, which we'll be able to send lots of people to our cause because they'll be able to read about things and understand it. I've got a new channel that's very similar to this. Oops. Am I still broadcasting? Hello. Hello. I'm going to get off of this and see what happens. Hello. Okay. I think we're okay here. Oh no, it seems like it lost. Did it lose it? Oh no, we're live. We're still live. Okay. All right. Sorry about that. There was a. I'm going to use my phone here because I think I had too many computers going, and sometimes I've got this going. It's transmitting. I've got a website, and then I've got two other things on the Wi-Fi looking at this. So, and I got pretty high speed stuff. So I apologize. Anyways, check out the YouTube. Okay, I will. Of course, that duplicate. I love Jimmy Dore. Yep. And like I said, hey Lisa, I have a big surprise coming up. Probably sometime next year, even though I've already started the concepts for it, and it has to do with progressive, and it is going to be absolutely awesome because once we get our Science Woke .org website up, which will allow anybody to come in who is a person who's curious, a person who knows things aren't as it seems, and they go, hey, you should check out this site. It's going to tell you how to become science woke. It's going to tell you the problems in mainstream physics. It's going to give articles about what those problems are. We're going to give also scientists who are tackling all these things. I've got a new section. I still don't know the name for it, and this is one of the things I do want to ask you guys. I'll get back to this article, but I'll be right back to it. But I do want to come up with a name for it as suppression fights. The reason is there are going to be articles about on our website about all these. It's going to be a whole group of stories, and every time we find a person who's been persecuted is a good one, or suppressed, or whatever, persecuted. Maybe we should call them persecutions, but I need a better word for that. Again, I was going to call them fights, like the foe. Who's the foe in the fight? I don't know. We have to make it into something that if somebody has some idea about how we can do that, that would be good. But the idea is, and they'll come to this website. Well, the thing is there's a lot of progressive websites out there. I do know some of them. I have communicated. One is Nico House. I've communicated directly with him. I actually made a logo for him. He's got his Mikasa Sukasa network. He's here in Florida as well. I don't think I've not talked directly with him, but I want to get on their circuit one day, and I have a great way to do that. But I'm not going to reveal that right now because these things take time. So don't worry, I'm not going away with this. So yes, let's go back here now. We got some. I'm looking at the. Says it is sad that making a. It is sad that they are making a LIGO in space. Oh, there is? I'm not actually familiar with that. Lisa Hausman, sorry I'm late. I love Jimmy Dore too, but I'm growing to love Callum Maupin. I think I've heard of him or her. Working fine. Okay. Hello, fine chatters. That's Lisa. Hello, Lisa. There you are. Practical Truth. Wow, Dissident Science. I can't wait to see this one. Great to hear. Yep, absolutely. Duplicate as you know, blah, blah, blah. How about people who have been getting marginalized? Yeah, marginalized. That whole thing. I've got to come because what'll happen is on our website with Science Woke, I'm going to have things at the top like problems in mainstream science, and then I want to have something like fights. So what's fights? And you can say the fighting going on. I guess you could call it that, or suppression, and maybe just the word suppression. And then because what it's going to be one article with actually not that. It's going to be a whole page, and every time we have a new page, you're going to be able to look at a new suppression and the story about that. Then of course we have our other things, but I need to come up with that name, I guess. So any suggestions? Hi Dave, have you looked into the dissident figures work of Dewey B. Larson? Do you see any value there? Oh, I can take a look at that since people are saying this. I can actually go look these up and see if there's something I can do at Dewey B. Larson. I'll check it out, and I also know somebody else had mentioned something else. It was Fractal Truth said look at Theoria aphosasis. Okay. Anyways, let's go back to this article because it's definitely worth looking at. And it had detected, okay, we're saying much fanfare ensued. Basically, they're saying in 2000, they said that they had found indirect telltale signals of gravitational waves left over from radiation, announced they detected indirect evidence. Much fanfare ensued. Within weeks, however, serious doubts were begun to emerge. So, yep, serious doubts began to emerge because they probably weren't the right people with the right connections. I don't know. Within weeks, however, serious doubts were begun. Ultimately, it turned out that the collaboration had mistaken clouds of cosmic dust for a signal. Okay. Very interesting. The blow was crushing. So here again, what they're doing is they're setting up so that what they have done now with LIGO, of course, is right. I mean, we have crushing blows to anybody else who tried it because ours is the right one. We really found them. I mean, how could you question us? And so, these are really important ways that these people word it. And of course, you can tell then this writer, this journalist is very biased toward mainstream. He is basically a parroting person, as they say, as Dr. Alexander Unsker says. The gravitational wave community was sufficiently burned by the debacle. Say, look at this. I mean, burned by the debacle that LIGO opted for extreme caution and safety. This is so great, folks. I mean, come on. This is like, well, we what we did is we opted to be cautious and be very secret about it. So that way, if we published anything, of course, then you wouldn't. We can claim it being right, whereas these guys, they just blabbed it out and gave us their raw data, and then we could just go against it. Ironically, a big part of the reason collaboration is viewed with distrust in some quarters. Ironically. A big part of the reason collaboration is viewed with distrust. It's viewed with distrust because someone could show you wrong. So if you hide your data, you don't give out your raw data. There's a good raw data story in my film. Go check it out, einsteinwrong.com. It's $3. Go watch it. What does the money go for? Paying to have it so it has a service and be able to be on demand. That's all. Its researchers spent several months between the signal detection and official announcement in February 2016 to double, triple, and quadruple check their analysis to guard against another false detection. So how could this happen again? This is an interesting article, folks. This is way interesting. One of the most interesting ones that have come out in the past couple of years. First, it is highly unlikely that it has happened again. See, look at that. Who's writing this? A person from LIGO? No, it's a journalist. A journalist who wants to kiss the butt of big science so that they can hang out with the big boys and the Nobel Prize, so they can go home to their little high school reunion somewhere and say, yeah, I hang out, I write about those physicists with these giant brains that understand all those complicated things that no one can understand because they're unintelligible and paradoxical and they're wrong. That's why no one understands them. Anyways, sorry. But the answer is that separating signal from noise is very, very difficult in this kind of analysis. The signal is extremely faint, in the order of a billionth diameter of. I'm even not believing it now. A billionth of a diameter of an atom, and you're detecting waves of something you have no idea what it is or what the waves are made of. Shoot me now. That's why you need such sensitive detectors to pick them up at all. So this is why we are right and all those other people are wrong. Also, the universe is actually pretty noisy place. The problem isn't so much absolute weakness of the waves. The problem is that there are so many other distractions that so wiggle the interferometer. Guess what the criticism's about from the Danish scientists? It's about detecting something that isn't what they think. Wiggling, says physicist Sabarine wrote at Forbes back in 2017. It's Forbes. It's right. For the first time, Jackson's false signal claims were making the rounds. Look at all these guys. It's sort of sad. It's really sort of sad. It's sort of like Dr. Unzicker and my mentor, Dr. Riccardo Carazzani, say. It's so sad to see a waste of these people and their brains with this stuff. And I am not sure, Dr. Alexander Unzicker, I don't know if you're going to watch this or not. If you do and you get to even this far, basically, I'm not sure I agree with that. I'm not sure these people are that smart. Because they have to follow and they have to capitulate and they have to go against probably gut feelings or even things they know are wrong just to keep their positions. In large, LIGO's February 11th, 2016 press conference in Washington, D.C. This is so great. Washington, D.C., the place of the world's biggest liars, the people who are so against us, who hide as much as they can from us, who cheat us, who do everything, pass laws to rape the average person. It's just quite amazing when they announced the first detection of gravitational waves. Quick refresher, LIGO detects gravitational waves. Here you go. This should be listed as quick indoctrination. Quick refresher, LIGO detects gravitational waves via laser interferometer, using high-powered laser to measure tiny changes in the distance between two objects measured positions kilometers apart. Hey! Hey! Hey, mainstream. How do lasers work? Oh, you don't know, do you? because it's a wave. Oh, it's photons. Oh, okay, it's photons. But I thought it was a wave. So if it's a wave, you can't really have lasers. So light's only photons, but you talk about them as waves almost 95% of the time. So anyways, that's interesting. Okay, so detectors in Hanford, Washington, and Livingston, Louisiana. Here you go, Lisa. There's a yawn to you. It's back to you. Okay, let's see here. I'm going to make sure. Hi, David. Looked into this in science work. Okay, you have. I'll brainstorm and think of an idea. I have a phone. Nuclear. We got theory. Has some good theories on magnetism, but his ego's a bit daunting. Okay. Hey, well, at least I appreciate your critical thinking of that. I'm jotting down some of the people of these people you are talking about here in the chat. Oh yeah, absolutely. Dubka, I've been trying to figure out what it is about Walt Thornhill that just bothers me a bit, and I think you said it perfectly about the ego. I will stop this and come back to it. It's a very good and interesting comment. First of all, I praise the Electric Universe at the top level for a couple of things. They do really great marketing of what they do. But number one, number two, and number three is they at least create critical thinkers. Before, they weren't even talking about Einstein being wrong 10 years ago, 15 years ago. They wouldn't even mention that. Now they do. They're trying to come up with new models for the universe based on electricity. That's fun, or electric universe model. So I applaud them greatly because they're going against the mainstream a lot of things, even in their ancient stuff. But I will say, as much as I do admire them, I do think ego does get in the way. I think that's the difference between our organization. We just don't have that ego. I don't have that ego. I'm looking for truth like anybody, even when it comes to my own our own theory. My dad and I are the bigger skeptics than you guys are about our own theory. And so, is it right or wrong? He and I, if you ask my father and I if we think the universe is really like our model, even though we really do think it's the best model, I don't know. Honest to God, I don't have a gut feeling inside of me that it's right, because I think we have a lot of biases, maybe the way it works, but there is Walt Thornhill, David Talbot, I think it's David Talbot. They like being in the limelight. That's cool. I don't like being in the limelight. I like talking about this stuff, giving people information that I know. That's really cool. If I had a big audience, that would be cool, only because we would be creating lots of great thinkers, and then people could take and look at my dad and my particle model and say, hey, there's a better one. Let's throw this out. Fine. Yeah, the problem is there's, people treat Walt Thornhill as they sort of treat him like, he's sort of like the Neil deGrasse Tyson of the Dissident world and Electric Universe. I don't know. The times I've met him many times. I've sat at a table and ate. I don't know if we ate breakfast. Ate a meal together, but of course I did a couple conferences in conjunction with Electric Universe. Great people, great conversations. I always actually thought Walt Thornhill was pretty humble, but I'm sure with all the stuff that's being created by David Talbot, and he does great marketing, I will be the first to say that, and he talks about it. There is some way of power talking, I think is the way it is. I don't know. I've seen Walt Thornhill, and I think he has been talking as of late more with like almost the certainty of mainstream, because they have so many followers now. I mean, let's face it. They have over 100,000 subscribers to their channel. Of course, they've been around 10 years. If this channel goes around 10 years, they'll have 100,000, hopefully. But maybe even before then, because we have some big things that we can put out. But regardless, yeah, ego is really hard for people, especially when they actually become so, they fall in love with their own theories. Look up dissident science, fall in love with your own theory. I got a video on that. Let's see. So that was answering the question about wall thorn. It just bothers me a bit, and I think you said it perfectly, ego. Yep, that's what I did talk about. Laser interferometer space antenna. It's going to be the LIGO in space. Okay, thank you very much. The Haas. Wall's a little edgy, but palatable. Yeah, I think that's the way I would put it. Yeah, I agree with you, Duplicat. Duplicat, yes, I don't object to him thoroughly, but by any stretch, I really enjoy his information. Just something a bit off-putting, yeah. Yeah, I agree. But again, stop yawning. Absolutely. David, the bottom line is you are approachable with an excellent quality. Well, oh, that's nice. With that, I'm actually going to bed, and I will be listening. Okay, well, when I lived in Brazil, I was in a place where a person had me come and talk to them, like I'm talking to you, and they'd fall asleep, and I could make them fall asleep just by talking. So hopefully I'm not doing that. These live ones are a little bit different. I think when I prepare, it's a little easier. But I'm trying the live one. Again, I think there's different things that come out of it. I think a lot of things on the side, I think that people like about it is new directions that I don't have when I have a more concentrated talk. Maybe that's it. So in 2015, both detectors picked up signals within milliseconds of each other for the very first time. The waveforms of the signals serve as an audio fingerprint, in this case, evidence for two black holes. I am sorry, folks. Listen to this. Both detectors picked up signals within milliseconds of each other for the first time. Okay, that's impressive. You've got two detectors in very different places picking up something. Sort of like when they said, quote unquote, in 1987 in the supernova explosion that they detected neutrinos at different detectors around the world. But of course, Karazani, go to neutrinos.autodynamics.org and you will see why there's a bunch of baloney there. So they picked that up. So, okay, that sounds pretty interesting to me. That sort of perks my ears up. The waveforms of those signals serve as an audio fingerprint. In this case, evidence of two black holes spiraling toward each other and the other emerging into a massive collision event, sending powerful waves across space-time. How in the heck did we make this leap from two detectors detecting signals that are so small they're a billionth the size of an atom in two different places to, oh yeah, oh by the way, it's this extremely specific thing. I mean, listen to how specific this is. It's not like we think we detected a gravitational wave we're not sure that came from, or it's a gravitational wave, but according to everything, that's what we think. Now that would have been an answer, but no. The waveforms of these two signals serve as an audio fingerprint. Oh, okay, for detecting gravitational waves, right? In this case, evidence of two black holes, not one, two, spiraling inward toward each other, not away from each other, not dancing around each other, but in toward each other, and merging into a massive collision event, sending powerful shockwaves. I think they're smoking stuff, man. I mean, how did they get from this? I really do. I really think at times they're so in their small bubbles talking, getting so excited about this, and their theories are so unicornian, so Harry Potter, so fabricated, and they're living in this world, that they really do sit around. Maybe they have too much to drink. Maybe they are smoking, hey, I'm liberal person, do what you want, as long as you're not hurting anybody else. But how do they get a leap to that totally specific thing? This is the signal that Jackson's group most strongly disputes. You think they're probably sitting around going, We don't even you don't even know how anything works in the universe. Mainstream has no clue. And you're telling me that it's this thing? Well, look, I'm just going to look at the signal and just start there. Correlated noise. Gravitational waves. Now, I guess what's happening is we're going to get us schooled. Remember, they're going to say they're going to school them. Remember how they're schooling those Jackson and his crew over in Denmark for like 2.5 years? And they're going to school us now. This writer is definitely super biased toward the mainstream, and he knows that gravitational. This is the one, not the ones before, and you guys can't prove us wrong, even though we're very secret about stuff and very careful. Correlated noise. Gravitational waves travel at the speed of light. Remember what I did say, in our particle model. We did say gravity travels. Now, get this, okay. Here's some problem. Listen to the problem here. Take a look at my father and I's model, just for one example. Or you can take a look at an ether model. Let's take a look at an ether model. Ether model says gravity is done, there's a lot of different ways, actually. There's like 10 different ways ether models try to describe gravity. So anyways, go back to our particle model because it describes both, so it makes it easier. Okay, so gravity and light are the same particle. They both travel at the speed of c. That gravity gets here and light gets here at the same time. The only difference between light and gravity is that light comes, our particles that come in waves form. Just like if I hit you, if I want to break something like this badge, and I want to break it, I'm not going to break it by just holding it like this. I'm going to break it by doing this. So that's why light has effect on us. That's why light's important. Why light also can travel. So anyways, what do we have? We say gravitational waves travel at the speed of light. Well, here you got a problem. Gravity travels at, and according to our model, gravity travels at the speed of light. Light travels at the speed of light, same particle. Gravitational waves travel at the speed of light. Now you have waves of gravity. So what model do they have? I can't picture it. So no matter what you say, even in the sentence, gravitational waves travel at the speed of light, but since the gravitational waves travel, but they say gravity travels at the speed of light. The mainstream will say this over and over. They'll say, how fast does gravity travel? They're going to say the speed of light. So you have gravity waves travels. You understand why not having a model? Why I go freaking nuts when I see a sentence like this? This is why I'm your science therapist. You're sitting there reading this like little innocent people. And of course, you're not little and you're not innocent because you're watching this. But anyways, being sarcastic here. But anyways, this is why I'm here, trying to point these things out to you. And the only reason I see this is because I have a model, at least in my mind, that I'm trying to give to the universe. And this stuff right here, right over here, tells us, gives me a sentence that is so full of problems that's why I'm saying this isn't a problem that's, we didn't get the signal, so when we get the signal, we'll find it. I mean, that's what they could say. They says, well, maybe you're right. We didn't get the signal. Let's keep looking for it. We're going to have to do this to find that signal. They don't even do that. But I'm saying that, no, the problem is super deep. They don't even, gravitational waves, and light all travel at the speed of light, yet they do not have any physicality to any of that. And especially gravitational waves in gravity, which already travels at the speed of light. I guess the way you could see it, I'm going to try to think of their side, that so you have this bending space-time, which is sort of like this, if I were to give it physicality, it'd be like a lattice or something that's sitting there, and it's there so that it's warping, the mass warps this, so gravity's sort of stationary, but then you have the problem, but how that model doesn't fit it. I'm sorry, I cannot, it's a paradox that's impossible to solve. And this is not something because it's complicated and I need to understand. No, it's impossible, paradoxical. The only way I'll understand it is capitulation. What is that? Capitulation is I have to finally just say, yeah, it's true on faith, even though it's illogical and paradoxical. The textures are so far apart, there should be a slight lag time and a small adjustment in amplitude according to the curvature of the Earth. The signals will be correlated in data. The noise, however, should not be correlated. The Danish team concluded from its analysis that the noise was correlated at both the Hanford and Livingston detectors, potentially contaminating the data. For Jackson, this called into question LIGO's ability to sufficiently distinguish between signal and noise, hence the validity of the detection itself. So whether they are questioning it is something that's really important when you do these kinds of experiments, and that's called simultaneity. Now you have two detectors. I can't say it. Two detectors in two different places. It's the same problem when you have several GPS. You've got a GPS satellite and you've got your signal on the Earth, and you're transmitting signals. Well, you've got to synchronize. Synchronization is even better than simultaneity. Synchronization. So you have a problem where you're detecting something. That detection is of something that travels at the speed of light. So we know if you have two different detectors, they're not going to get the signal the same. In fact, no detectors will ever get the signal at the same time. Even if you sit them next to them and say that they're calibrated perfectly, they're not going to. That's according to infinity and the way the world works. There's no two particles that are identical. If you are a critical thinker in the new world of physics outside of mainstream, that's a lot of us would say that. So the signals. So they're saying that, of course, that the Danish team concluded from its analysis that the noise was correlated at both the Hanford and Livingston detectors, potentially contaminating the data. For Jackson, this called into question. Okay, so here it is. And I guess this is the explanation of this. A correlation in noise would not affect the individual signals at each of the sites, but in order to achieve the highly significant signal between the detectors, LIGO collaboration takes into account how both signals are correlated. If the correlations were not reliable because, for example, there was the possibility that the noise correlations contaminated its data, the statistical significance of the detection would be reduced. In other words, what appears to be a signal might actually be caused merely by fluctuations. Hussenfelder expressed some doubt about Jackson's claim at the time, concluding that his group likely must have made a mistake in its analysis. Look, you know what? These aren't scientific arguments. They're just like, they're going, you're wrong. You're wrong. That's all that says. The claim that concluding this group must have made some mistake. That's. Look, you're supposed to be. What is this? Correlated noise. But before we were talking about what? Reasonable doubt. You made a mistake. That's why they're wrong. You made a mistake. What is it? I have some double talk up here because when I started to read that, I was trying to follow the logic. It's very hard. And usually when it's very hard, it's not clear. Guess what? The Danish analysis is just wrong. I mean, they say it. This is like politics. It's like when, you got politicians now just telling you to your face, of course, we give tax breaks to the rich. And yeah, they're supposed to, it's supposed to trickle down, but it doesn't. They just buy another yacht or it just goes in their bank account and they don't even notice. But they don't buy 1,000 pairs of pants now. They don't wash their car 17,000 times. They just go and say, yeah, we give them breaks and it probably doesn't trickle down. They don't even lie to us anymore by saying, trickle down. Economics will. It's good for everybody. That's how that's how the world goes around. All right. Danish analysis is just wrong. I'm going to just keep it there. I'm going to go to my comments right now, so that I can read them. Well, good. Appreciate everybody being here. Thank you so much for coming by. Debbie, I wish you could be more on. I'm hoping to get back soon again. Classy group here. Oh, my subscribers are classy group. Very good. I'm going to, okay. I went a little off topic, but I do believe light is not affected by gravity, right? Prince Polka. Good question you asked. The question, Prince Polka says, do you believe that light is not affected by gravity? Okay. Number one, here's my question to you, Prince Polka. First of all, we know mainstream has no model for any of this. They just says it happened. They just said it happens. In fact, Einstein said it happens, therefore it happens. Couple of answers, quick answers. NASA scientist, one who worked most of his life at NASA, working with laser and laser visual, I don't know, interferometry or whatever, basically says that they do see light bending in the corona of suns. Of course, the corona of the sun is known to have mass there. A corona sun is not empty space. There's mass. And if you put a stick into water, you stick a stick into water, it will bend. You can see it bend. That's light is bending. Well, the same way happens when you have light going through a corona of the sun. But the moment they get outside the corona of the sun, they do not see starlight bending. That is against, and it's complete evidence against general relativity. Now, if you have a model, you have to either adhere to that, or your model must tell you how that works. So the answer to your question is, number one, NASA scientist says, nope, doesn't happen. It doesn't mean that we don't see bending of light out in space. Yes, we do, because light does go through gases and all kinds of stuff, coronas of suns, which is pretty intense place. So yeah. And the other thing is, too, is you need to have a model. What model do you subscribe to of the universe? And if you say mainstream, I'm going to tell you it ain't a model. Space-time is not a model. It's not a physical anything. It's mathematics. So that's your answer. I think we need to understand more precisely what gravity is before we can know what. Lisa, you are answering. I am now passing the microphone over to Lisa, and I'm going to go lay down and listen, because I'd love to have somebody talk like this to me. Not have to be me, but you are. I've impacted people for good or bad. I don't know. Bad influence, maybe. A little off topic. Okay, so okay. Prince Polka, I don't believe in bent space, but I do believe Newtonian gravity. I believe light is affected by gravity just as negligible because of the gravity speed. Again, Prince Polka, please, 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 every time you say that, you have to say to people, this is what I think it is. So just talking about it in isolation is not good. I'm your science therapist. I'm here to tell you many decades of being with brilliant minds who talk about this. Be very careful. You can't just talk about light bending gravity in isolation. You've got to talk about the model of the universe that you're using and why that happens. Having a feeling or gut feeling, don't want that. Again, I'm not here talking bad about you. No way. I'm here to point. That's why I'm having these. Hey, trying to find reasons for why everybody does these live ones. I say, okay, I do live versions. Well, that's one of the reasons, I guess, doing the live version. That's pretty cool, because we can answer questions and I can help you out, even with the statements I'm seeing you guys talk about. Alrighty. I really have to go, but I'm fascinating stuff. Okay. How wonderful you, ladies. Okay. Ben Reddick. When you script a fairy tale which has been told and retold for 100 years, anything and everything is possible. Absolutely. In fact, for everyone to know, a lot of us claim that Einstein was really a huge detour to a dead end. And not because of relativity or anything, because he came along and gave rules to the universe. You can't go faster than the speed of light, which you can. I'm just saying we can travel faster than the speed of light. I do look up dissident science, speed of light, c, dissident science, speed of light, c, and I do talk about that. why it's so hard to do. But yeah, we have, in our model, we have things going c squared. So if we do G2 gravitational at the second level down, if we make communication with that, which is light and gravity at that level, we can communicate to Mars in 0.4 seconds. That's pretty fast. So, we need to know, yeah, absolutely 100 years. So let's get back to the comment by Ben Reddick. Yeah, Ben, what we say is that, yeah, he said that everything is the same in all inertial frames. You got a huge problem with that. That's paradoxical in itself, because then what's inertial frame? So if this has an inertial frame, meaning as a frame of reference, and its inertial frame is traveling with mine. Well, this is made up of a bunch of atoms. Atoms are made up of nuclei and things going around them. Those have a speed, so each of one of those particles is going to have their own reference frame. They're sort of moving together, but they aren't, because they're doing in spiral forms. So every one of them, so how can you say this clock on this? You can't. Just stop. So the whole idea, so basically Einstein started this terrible precedence of that we are so smart now, our brain, we become so enlightened that we can come up with the laws of the universe by observation of, or feelings, or some thought experiment we've had, and then we go around fitting the world into making sure it doesn't violate that. And that's what we've done for 100 years with Einstein. Then we started inventing particles, because we used to find particles or find things like the electron, and again, it's called electron, but we were finding some beams of stuff. And then all of a sudden we started doing things like we were inventing the neutrino, because we think there's more energy there, and it's not. So we'll invent the neutrino to take away that energy, and then we'll find a lot later. And then we'll we have electrons and protons and neutrons. So maybe protons and neutrons are made up of smaller particles. Maybe it's made up of one particle called the quark. And those were invented. And of course, that's absurd, because there's like 6 quarks. They're all different. They have all different. So how could it be one thing? And what does that mean to be one thing anymore? It's like a species. Maybe they're all the same phyto or family, or what do they call those things? And so the 20th century has been completely an invention. And according to myself, let me put it in first order. Well, that's true, because I before I knew Alexander Unsker, my mentor was Dr. Karazani, and a lot of those particles, he also said, had to be thrown out. So something that Unsker said, Karazani said, I now subscribe to that as well after looking into it myself, which you need to do. So very good. Lost Horizon 52, aka David. Yes, David. In every sentence written is so many of these articles is embedded dozens of assumptions, and any of which may create blocks in understanding what actually underlies the forces we. Is there more there? I think there is. I'm sorry, but I get it. Yeah, absolutely. Absolutely. It's really hard. I mean, being a critical thinker going through these, I think the most important thing is funny, because my mom, when I was making the documentary, she became a critical thinker, and she would read these articles the way I do. And I remember, talking with her. I'd go over, or even talk with her, and she goes, I was reading an article, and you know what she told me one day after she became a critical thinker? She did like many of us. Can't read them anymore. I read these now because I want to go through them to get you guys to understand where these things go wrong and where these articles go wrong. But I can't watch the Discovery Channel. I can't watch the Science Channel when they're talking about these crazy things in cosmology or in physics, and they just talk about them like they're real. And you see people like Neil deGrasse Tyson talking baloney on the, you just want to choke him, because they're just doing such an disservice to science. So anyways, the Danish analogy is just wrong, and really that's all this gives you a clue that basically says, folks, they really don't have a good answer back to it, because when they just punt and say they're just wrong, that means the other people could be right, and they're just not going to admit it, and they're just going to say that's all I can do. LIGO and data analyst Neil Cornish of Montana State University told Science, because you know why they're just wrong? Because we're all attached to the Nobel Prize. That's my claim to fame. I got a raise for that. Am I going to lose my raise if it turns out that this signal wasn't? And what happens to the Nobel Prize? The Nobel Prize Committee, which is supposed to be critical thinkers looking at the world, trying to find the people who are going forward, who are giving prizes to people. Well, it's incestuous. This is sort of like the politicians who get money from big pharma so that they can, charge too much for seniors for medicine around the earth, so that the seniors are going, should I eat today or should I take my medicine? Well, change your diet. That'll help. We eat terrible diets because they want that. They want us to eat crap so that they can give us medicine. That's going to be on my other channel, Science-Wise. Adding to Jackson's group used simplified analysis to make some very basic mistakes when deciding how to go about analyzing the raw data and accounting for noise. So let's go back to this LIGO data. LIGO data analysis. Neil Cornish of Montana State University told New Scientist, adding that Jackson's group used a simplified, see there you go, don't understand the complicatedness of it, and made some very basic mistakes because, again, they don't have the super brains we do, when deciding how to go about analyzing the raw data and accounting for noise, which is basically everything. It's not like they talked about one thing or what. No, they're just about how their entire evidence was found. Something small like that. While Jackson has considerable expertise in signal analysis of large data sets like CMB, he does not work directly on gravitational waves, which are very different beasts. This is the same thing. Again, this is the same thing. It's a way to say, you don't work on it. You don't do this every day. It's like the particle physicists. We have these people. That's all they do here. Don't tell me that this entire it creates false flags and is flawed everywhere, and that an engineer in about 2 hours' time would pull his hair out and just take out a gun and shoot everybody, just saying, you people deserve not to even be on this planet, because what happens? Oh my goodness. Well, anyways, obviously, what it means is that these people, they would just say, fire all you guys and start over. It was an analogy, folks. I always have the analogy. I shoot myself, there you go. So anyways, they're coming to LIGO's. Okay, so basically, he does not work directly on gravitational waves. You mean you don't give the data, that it's in secret? Because if you gave the raw data out, they could then find, well, I don't know, maybe they did. Maybe that's why they can do it. They're coming to LIGO's data with the tool set they've developed for this other field. Isn't that sort of kind of like double checking it in a different way? And big data is big data. I work with big data. I work in a supercomputing group. I have people there in machine learning, just basically looking at large amounts of data statistically. With a tool set they developed for the other field, the cosmic microwave oh man, they've got the Apple detector, and we are talking about unicorns. There you go. Okay, so apples are, says Shoemaker. They are determined to use their concepts and not try to learn from our sometimes bitter, long, and frustrating experience. This is so good. This is, like I said, this is the best article that's come out in years. The analysis done by Jackson et al. looks for residuals after subtracting the best fit waveform from the data. Because the subtracted theoretical waveforms are not perfect reconstructions of the true signal, they never are, since we have a discrete set of waveforms that we use to search the data. They find residuals at a very low level and claim that we have instrumental artifacts that we don't understand, which could be very true. So therefore, he believes that we haven't detected a gravitational wave. In other words, Jackson's team searches for collisions using a limited set of modeled signals. but the actual collision will produce signals that invariably differ from the model ones in some details, the modeled ones in some details. And according to LIGO doesn't use this method to make statistical statements about its confidence in detection. Again, what it seems like to me is that someone else is taking a different look at the analysis of the data with a fresh pair of eyes, with different techniques they've done. And from what they are seeing, they're saying, well, the way these people are doing it, and my guess is that people in Jackson's team do know how LIGO does it. And what they're saying is, according to our analysis and the way we do it, what this could easily be simply noise. Now, that doesn't have to be the same analysis. The claim of its noise isn't because, basically this is the old thing. You can fit your data analysis, you can fit to your rules that you're using to say that this is a real signal, to fit it so that, it's a real signal. But if you have somebody else look at it, if we had our machine learning person look at it and run machine learning algorithms, which there's probably at least 10 to 20 to 30 of those, and they found something and they go say, this basically is noise. And this is another thing I love, and this is one of the big problems I always talk about. I'm going to get to you guys. I appreciate you guys sticking around. I'm going to get to your questions and comments here. I know people are coming in and out because, hey, it's a long night. Appreciate you people. We got 7, 11 to 12, 13 people out there. Greatly appreciate you coming by. Artist's illustration of 2 merging neutron stars detected by LIGO. Collaboration. Here's another one. Talks about this a lot. Dr. Alexander Unsker, read the book. Collaboration. The collaboration, when I read that, is a word full of meaning. It means lots of people trying to pile on to get their Nobel Prize fame, whether or not you get the Nobel Prize. I worked on the team that helped do something that got a Nobel Prize. And of course, that's going to be big. That's going to be raises for you. I can put it on my resume. I can put it on my accomplishments for this year. I now have that reputation. Students are going to come to me in awe. They're going, oh, and all that stuff. And then, of course, collaboration also means that we will come together with and put together rules of how we're going to find this stuff, what it all means. And that collaboration means that I have lots of people together that actually are going to back each other up and support each other. It's a support group. Perhaps the best argument in favor of the validity of LIGO's detection is the number of additional detections it has made since then. Most notably last year, the binary star merger supported by simultaneous gamma ray bursts and signals at the rest of the electromagnetic spectrum. Jackson tries to explain that away too, but his argument rests on the fact that LIGO initially thought that the event was a false alarm since it coincided with a glitch. LIGO successfully removed that glitch from its data, but Jackson simply doesn't trust its analysis. For all of the sound and fury, the Danish group's position is a minority opinion. There we go. Here we go. Remember the collaboration? Minority opinion means it's wrong. But if you think about paradigm shifts in science, guess what happens? Minority becomes the majority. The immediate that the Democratic Party is not favoring one candidate because, hey, we leave it neutral so that all you vote and give us money think it's neutral. Oh, we don't. Guess what? That was like a conspiracy theory that we did. That's a conspiracy theory. Until WikiLeaks dumped all the emails into our lap that show the collaboration and the conspiracy right before our eyes. So, it is a minority opinion. For those physicists who went on record with the new scientists in support of the Danish team analysis still think that, in the end, that LIGO results will hold up. So here's what they're saying. They're saying, okay, maybe that was a false signal, but the rest weren't. That's for sure. But of course, it's really interesting to me. Here's my problem. It says the most notable is a binary star merger supported by a simultaneous gamma ray burst. Since they do not know what light is, they do not have a model for gravity. They don't have a model for light. They don't have even a model for gravity waves. This is all conceptual. To me, yeah, their detectors are going to have some thing happen at this. Are those gravity waves? Of course not. We don't know. First of all, the concept of the way they say gravity waves doesn't even work in my head. It's paradoxical. Gravity travels the speed of light. How does gravity waves travel the speed of light? How does light travel at the speed of light? What's their model for all that? For all the sound and fury, okay, we said that. Their emphasis needed to be independent confirmation of LIGO analysis. Even the physicists who went on record, but okay, hold up. Their emphasis is on the need for independent confirmation of LIGO analysis. That's cool. On that point, people seem to be in agreement. But Ritz counters that the complete data for that first run is already available online. Whoa! Don't do that. That means somebody's going to come along and show you wrong. I'm trying to get this scrolled up here. Sorry. There we go. All right. So anyways, available online. According to Shoemaker, this includes the relevant time series data and the programs used, but is not a trivial matter to use them. They're just like, you little boy. Yeah. I want. You can't use it. Tapping him on the head. You're not smart enough to use it. Caltech even held training workshop on how to deal with graph. They'll tell you how to find them according to the way they find them. That sounds independent to me, doesn't it? It's not called confirmation biased. That's a pretty far cry from asking physics community to take its analysis on faith. Yeah, here's the data. You really can't do it yourself, so let me show you how to pick. Let me get my mouse here. Here's my mouse. Let me click on the program. Run! I just confirmed it. That's better than just analysis on faith. No, it's not. It's exactly the same thing. And contrary to Jackson's assertion in the article, a technical paper really is in the works at LIGO collaboration detailing how it has handled the noise in its data. Noise just hasn't been a top priority. Oh my God, this is like when Alexander Anderson says that the papers that are written mostly about the Higgs boson, it's a super top level, about how it fits into the universe. As you get down to anything that has any degree of technicalness about actually how they do it, it goes sparse and far between and non-existent. So even though detecting signals by definition is finding something that isn't noise, it's not where is it here? Noise hasn't been a top priority. It's the only priority. To find something, you gotta see it's not noise. Shoemaker concedes this has given LIGO a needed nudge to complete it. Oh yeah, they said this. You know what it was? This thing here is upside down. Oh, okay, now done. We have now completed our analysis because this was upside down and now is right side up. So therefore, we've been careful to write a paper that is not a rebuttal of Jackson, because if we do, he'll just come back to us and say we're wrong again. Since I don't think that would be very useful for the community. Yes, yeah. Translated. We may lose our raises in the meaningfulness of what we told everybody was really important things that we found, even though they don't understand anything. But they did give me a 16% raise the time I actually worked on the team that won the Nobel Prize, because this was a big thing that they could put on their website to attract more sheep to our physics department, so where they can capitulate to paradoxical and unintelligible and complicated and groupthink stuff. Instead, it will be more didactic about specific points where we see they had difficulties. Folks, this is just too much. Okay, folks, I'm going to just get back to people's comments. It's 10:30, so I don't want to go too much further on. Let's see what people have been talking about. Yes, David is very sentence written so many things. Yep. Let's see. Debbie, we create all these filters to change the data to extract out what we believe is noise, but anytime you filter out, you assume to some extent, which is non-correlated bottom line. Yeah, that pretty good there. Lost Horizon 52. You are assuming that some extent of the very model you are trying to prove. Yep, absolutely. Steady state is back after. Okay. Steady state is back. Fred Hoyle was right. He would turn in his grave with what goes on today. Big Bang doesn't make sense to me. Keep up the good work, and we are with you. Well, thank you very much, Dan Hards. Dave Thuman. Does Karazani get any references in the CMPS preference proceedings? Have any influence at getting group members to take his work seriously? Hope you are having a nice evening. David Thumb, truth is, yeah, I am his big supporter. I talk about him. I'm the only one who does. My dad does talk about him. I've written papers. I think I've written 1 or 2 papers that are really basically support his work. So that's the way I do it. Dr. Karazani doesn't want to publish anything in these. I'd like to publish them. So that's why I put everything on autodynamics.org. He is going to be and is a featured scientist on sciencewoke.org. In my opinion, his argument against special relativity is the best out there. I've not seen anything better, although I've seen more anecdotal ones at a higher level, like my father's is one, and other people who actually have some very good arguments that are easier to understand. But when it comes down to a mathematical analysis of his work, very good. His equations also basically turn all the relativity equations into Newtonian ones. He was the one who inspired my father. And, well, we tried to do his experiment to detect gravity as a wave. Boo! There I'm talking about gravity waves there. It's on the brain. You get those hooks up in your brain and they just come out. It's called garden path sentences, where another word comes after, just like on your phone. They have garden path sentences all the time. You type a word and they try to tell you what garden path you're going down at that time statistically. Anyways, I was talking about Dr. Karazani, and his work definitely, and I've lost my train of thought. Go down the garden path and I got totally lost. But anyways, I work on that constantly. Try to, I'd like to get his papers are published. Going to be going here very soon, and so yeah, I think his work is the best. And he discovered, in my opinion, the knockout argument, both mathematically and physics-wise. Very well done. He was he was between the ages of 20 and 24 when he did that. His audit. I was talking about the gravitational experiment. He had specified an experiment to show gravity as a graviton, that is a particle, and from that our entire particle model came. And so his equations are Newtonian, so they do work better in even nucleus-nucleus collision. Again, go to autodynamics.org. I have that website set up for everybody. Paul Whitner wants to ask, what is energy? That's an easy answer. Energy is, there's several answers to that. At the top level, energy let's talk about it at the total philosophical level. Energy is a concept. It's not real. You cannot hand me so much energy. When people say, I heard a guy on his channel who has his own theory, who publishes very often. He basically says, "Oh yeah, and this energy is moving around." No, energy doesn't move. Energy is a concept. What we use energy for is, in my opinion, what we sort of use that word linguistically mean. It means some type of thing that we have in mass or in flux, like energy from the sun. Of course, if it's a model like ours, G1 particles that are coming down. But regardless, it's the idea that we use the word energy as sort of a potential for doing work. The gasoline in your car, the alcohol in your car, the natural gas in your car, the methane, the hydrogen, the in different chemicals that are in rockets. That has a not a it's potential interest word, but it has a what we consider to be work sitting there to get that big BF rocket from SpaceX up into space. We know how much to put in it, and we can use these energy as a transformation of being able to give us some way to calculate certain things. Help us calculate between different types of things that we have in models. So basically, energy is a concept. It is not real. It's a useful concept when we're doing calculations for things that we want to do work. It's a useful word because it says there's a lot of energy potential in this, meaning it's something that we can harness to do useful work. That's the way I would put it. David, thanks. Any updates on the coming audit angles? Any updates coming on the? No, David Thumb. I'd be welcome to have people help out with it. But the only thing I can say is that on sciencewoke.org, we're going to have Karazani there. I'll obviously be writing about that. Nothing much. I don't even know really too much about how he is, if he's still alive even. I greatly appreciate, his work. I'm a champion of his work. We had a sort of a falling out. I know my 50th birthday party, he did appear. I think he's gratified. I think there was a lot. I think he was hoping my movie was going to be about his work only. I think I'm doing his work way better than maybe he imagines, because I'm fitting it into the big picture of everything else I've learned. The model that my father and I have is direct in relationship. The book that I have written with my father, which is not done, and we keep having a million versions of it. It will be done sometime. It's actually dedicated now not only to Dr. Riccardo Karazani. It's also dedicated to my mom, which I think is really great too. Is this one of the more recent ones? Yeah. There we go. To Dr. Riccardo Karazani and Patrick and Patricia Ann DeHilster, my mom. Here it is, folks. Look at this. Universal Hack. Reviewer's copy. A no-math physical model of the entire universe. Pretty cool. Look at that. We got all kinds of diagrams in here. Oh, this is a cool one. Lots of graphics that don't exist anywhere else. Oh, look at this. Models of how light works in. Pretty cool. Could be all wrong. How many people tell you that about their own theory? Alrighty, folks, I'm going to go. My goodness, it's probably way too late already. I've got 9 people. I want to thank all of you guys for supporting this channel. let people know. Also, like I said, subscribe to my father's channel. He hasn't been doing stuff, but it is certainly great. One thing I would say about my father's channel that is really, really fantastic is that he has ability to take something that seems stupidly simple and making extremely interesting. Like one of the things he talked about was, does the moon rotate? When you start thinking about it, it's not an easy answer. So, anyways, particle guru. No, look at that. YouTube.particle.guru. No.com. No, in place of com.guru. Also, we have Nick of Time. I think it's nickoftime.guru. YouTube.nickoftime.guru. That'll get to his website. Really great stuff. You like to listen to a person who is a super expert in time dilation, special relativity, that kind of stuff. He's got one video that's does quite well. I'm going to have to talk with him, but he's another person. And Jeff Yee too. Great videos. I love Jeff Yee's videos. Those are all part of our team work out there. And again, thank you so much. I know you guys are bopping off. But remember, as I always say, stay critical, stay thinking. I'm Dave D. Hilster. I'm your science therapist. Ciao for now. I do have more videos coming. We'll make a video actually on this article, but it'll be more concise. But you've already sort of seen it. Okay? Thanks so much. Good night.